Right. Last class, what we learned was how the decomposition happens in general stoichiometric reactions. Today, let me introduce you to gravimetric analysis. Okay. Gravimetric analysis. Now, gravimetric analysis, right? It is more like an interpretation of chemical reactions in various ways. The type of analysis which we will do is mass and mass analysis and mass and volume analysis.
Sir, your writing is not visible on the screen.
One second. The other one is mass and volume analysis. Then we have mole and mole analysis. Correct. And volume analysis. These are the type of analysis you will notice. Got it? Let me explain you everything with one question. Simple question. So example 1, you see, if you have KClO3 and you know that it will decompose to KCl plus 3 moles of O2. Okay. So according to the stoichiometry, you have to check out the mass-mass ratio. If you have to check mass and mass ratio, correct, it would be 2 times of, because I'm putting a balanced equation now, 2 times of 122.5, and this will be 2 times of 74.5, and this will be 3 times of 32. Correct? This is the total mass. Yeah.
Yes, sir.
I'll keep my video
Yes,
off
sir.
for some time just to make sure you get enough bandwidth. Okay.
Okay, sir.
So you can see this is the ratio of masses at which it is present. So what we can say is that mass ratio here, mass of KClO3 divided by mass of KCl, that must be right. I mean, you can compare the ratio of these two, or you can compare the ratio of KClO3 and O2. Then, if you are taking a mass-mass ratio, that means we are doing a mass-mass analysis. Okay. So here it is like 2 times of 122.5 divided by 2 times of 74.5. So this is a mass-mass analysis. How mass ratios are present in them. Got it? Similarly, I can have mass of KClO3 with respect to mass of O2, and that would be 2 times of 122.5 divided by 3 times of 32. This is mass ratio. Now let me tell you how the mole ratio works. Mole and mole ratio. So check this example. I need to, let's say, calculate weight of iron, weight of iron, which will be converted, into its oxide, by action of 36 grams of steam. Okay. The given reaction is like this: 3Fe plus 4H2O is going to give us Fe3O4 plus 4 moles of H2. Okay. Now notice moles of Fe with respect to moles of H2O will be equal to 3 by 4, isn't it? So which means moles of Fe will be equal to 3 by 4 times of moles of H2O. Moles of H2O will be 36 by 18, correct? So that makes
Yes.
it 3. So therefore, weight of iron is equal to 3 by 2 times of 56. 56 being the atomic mass of iron. Hence, you will get the answer as 84 grams. Okay.
Okay.
So what we are trying to say, we have done this already, but now we are trying to explain how we are using the mole concept here. This way of using is called as mole and mole analysis. Okay.
Yes, sir.
Got it? Any doubt here, beta?
No, sir.
Right. Okay. Similarly, we can have mass and volume analysis, which we have already done. Like when you are using STP conditions for gases, that is about volume analysis. Okay. Right. Now let's look into this next type of gravimetric problems, which is based on these two important terms known as percentage purity and uh, percentage yield of product. Okay. Now we are entering more into the JEE dynamics as well as more of NSO type of questions. Okay. So here I'll explain everything by question by question here. Check out. Here it has been given how much marble, keep a book and pen with you as well. Okay. 90.5% purity would be required to prepare 10 liters of carbon dioxide 10 liters of carbon dioxide at STP when marble is acted upon dilute HCl. Okay. Now, honestly speaking, you would not be given the equations in such kind of questions because by the time you finish your syllabus, right, for NSO syllabus, you're expected that you should know these kind of reactions. Okay. The marble here is always referred to calcium carbonate. And when you're adding with HCl, you would be expecting this to form CaCl2 plus H2O plus CO2. Okay. Which suggests that if I take 100 grams of calcium carbonate, you can see as a mole sign, you can notice that it is giving 1 mole of carbon dioxide, which is equivalent to 22.4 liters of gas at STP. Okay. So if the question says there is only 10 liters of carbon dioxide at STP is being observed, therefore I can say number of sorry weight of calcium carbonate which is genuinely reacted to make this 10 liters will be 10 times of 100 divided by 22.4, correct? Isn't it, Vita? These are called direct proportions. I'm sure you have learned in maths, isn't it?
Yes, sir.
So from here, I will get this as around 44.64 grams. This is the weight of calcium carbonate. Okay. But have you noticed something? Here 90.5 percentage of purity, which means this amount which you are getting is out of 90.5 percentage of something, some sample of marble. Okay. So therefore I can say 90.5 percentage, which means by 100 into, okay, into weight of the marble is generating the pure amount of calcium carbonate. Make sense?
Yes, sir.
Is this making sense? Yoshi? Yes, beta.
Yes,
Therefore,
sir.
that is equal to, this is given as 44.64. Hence, the weight of the marble will be 100 upon 90.5 multiplied by 44.64. Okay. So that makes the actual weight of the marble is 44.32 grams. 49, sorry, 49.32 grams. Okay. Is this idea clear?
Yes, sir.
Very good. Now, from here, I can say the percentage yield as a formula, right? As a formula, you can see, sorry, percentage purity as a formula, it is suggested that percentage purity is equal to mass of pure species divided by mass of impure sample, impure species or impure sample, that into 100. This is percentage purity. All good?
Yes, sir.
Very good. Okay. So whenever you see the percentage percentage purity, this is what we are referring to. Okay.
Yes, sir.
Right. The next term is about percentage yield. Okay. The next term is about percentage yield. See, for percentage yield, let me write the formula first. For percentage yield of product, because yield is always with respect to product, which suggests it is the actual yield of product. Well, you can write this in terms of volume, you can write this in terms of mass or number of moles. Accordingly, you have to take, the theoretical value. Theoretical yield, theoretical or calculated yield of product. Yoshi, are you there, bacha?
Yes, sir.
Right. So this is percentage yield of the product. Okay. Let me give you 2, 3 examples because percentage yield cases are more often observed in exams. Okay. So let me start with a basic example. Suppose if I have a marble, right, which is in a pure form already given, and that is decomposing on heating to form calcium oxide and carbon dioxide. At T equal to 0, if I take 10 grams of calcium carbonate, correct, which means it is 0.1 moles because it would be 10 upon 100, which makes it zero point 0.1 moles. Yeah, correct. So imagine if I tell you there is only 2.2 grams of carbon dioxide is observed. I will tell this as observed values. Okay, beta, correct. This
Yes,
must be
sir.
given to you. This information will be given to you in the question. But what you would do is you will check what was the original amount of the reactant. According to the stoichiometry, how much carbon dioxide you are supposed to get. See, 1 mole must offer 1 mole of carbon dioxide, which means if I have zero point 0.1 moles, I must get zero point 0.1 moles of carbon
One
dioxide.
more carbon dioxide.
So zero point 0.1
Yes, sir.
mole of carbon dioxide implies I should get 4.4 grams of carbon dioxide. And this is a theoretical yield. This is theoretical yield. Okay, beta. Hence, the percentage yield basically suggests that I'm only getting 2.2, which is the observed yield, but theoretically I'm supposed to get 4.4 into 100. That's how it becomes 50 percentage.
Mm.
The percentage yield is 50 percentage. Okay, beta.
Yes, sir.
All good.
Yes, sir.
Right. Let's try one more question in a slightly different form. See, 1 mole of KClO3 solid, okay, decomposes to release 2.27 liters of oxygen at STP. Okay, sorry, NTP. Take this. No, STP only, because I took 2.27. Yeah. Okay. I need to do find percentage yield of product. So what you will do, beta? You will check out KClO3. You know that it would decompose to form KCl and O2. There's a kind of hint you should catch up. So it is 2, 2, and 3. Yeah. So 1 mole must give you how many moles of O2? You can see 2 moles are offering 3 moles.
Yes.
1 mole must offer 3 by 2 moles,
Mm. 1.5. Yes.
theoretically. Okay. Which means it is 3 by 2 into 22.7, isn't it?
Yes, sir.
So theoretically, this many liters is what you are expecting. But how much you are actually getting? Only 2.27 liters. Hmm?
7. Yes.
Isn't it? So therefore, the percentage yield will be equal to 2.27 upon 3 by
2
2 times of 22.7 into
into
100.
100.
Correct? So
Yes, sir.
what we are getting? We are getting this as 10 divide 10 multiplied by 2 by 3. Correct?
Yes.
So
Yes.
which means it is around 6.66 percentage. That is the yield what you're getting. Is that all okay?
Yes, sir.
Right. Now let us mix in the similar way. Now what we'll do, we will mix the percentage purity also into the same question. Okay. So next, see this one. Find volume of O2 in liters at STP liberated by the complete decomposition of 245 grams of KClO3, which is 25% pure only. Okay, and offers a percentage yield of 75. Okay, this is how the question has been framed now. So what we know stoichiometrically is that 2 moles of KClO3 must offer 2 moles of KCl plus O2 gas.
3.
Barabar? Right. Now, here, if it is 245 of only 25 percentage pure, correct? So, which means it is 1 by the weight of the actual weight of actual or pure weight of KClO3 will be equal to 1 by 4 times of 245. I'm sure you agree with that.
Yes, sir. Yes.
So which means it is 61.25 grams. Hmm?
Yes.
61.25 divided by 122.5. That is the number of moles. Okay. So you can see
Yes.
number of moles of KClO3 will be equal to 61.25 divided by 122.5, which is 0.5 moles. Okay. So you know that 2 moles are offering 1 mole of O2. So 0.5 moles must produce how much? So number of moles of O2 would be 0.5 by 2, which is 0.25
Mm,
moles.
right.
Yeah,
Yes, yes, sir.
correct. So this is what you are expected. Okay. But unfortunately, even this moles is not we are getting. What we are getting, we are only getting 75% of it.
25%. Yes.
Correct. So therefore, the this is called theoretical yield. This is theoretical yield. So the actual yield of O2 would be equal to how much? 75 percentage. So 75 by 100 multiplied by 0.25. Yeah,
Yes,
correct.
sir.
Now this
Yes,
are
sir.
the number of moles is what we have, isn't it?
Yes, sir.
Correct. And if I put this in,
2 by 16.
percentage here, so you can see this
2
goes
by 16.
25 goes 3 times and this goes 4 times, isn't it? So it is
2
3
by
by 4
16, sir.
times of
Yes.
1 by 4. Yeah. And therefore,
2 by 16.
yeah, volume of O2 at STP will be equal to 3 by 16 into
2 by
22.7.
16 at STP. Okay.
So how much it is? 4.256 liters. Please go through it once quickly. Check if you have got the point.
Yes, sir.
Shall we go ahead?
Yes, sir.
Oh, sorry, sorry. I made one mistake. Sorry. Here it should have been 3. Yeah.
Yes, sir.
So I need to multiply that 3 also. Once again. Here, where is it? Into 3. Into 3. Into 3. Into 3. Okay. That into 3. That's why I was checking why answer is not matching. 12.76 liters. Okay. Hmm. So I think you got an idea about how the questions will be framed from this cases.
Yes, sir.
Next, let us understand the next terminology known as principle of atom conservation. Principle of atom conservation, usually called as POAC. Okay. Here it is another way of expressing, okay, conservation of mass. Conservation of mass with respect to one particular atom. You can take any one particular atom. With respect to that, we are assuming that there is a conservation of mass. Okay,
Yes, sir.
correct. Let me show you few examples instead of writing more theory on it. Let me show through examples. Here, acha, beforehand, just one thing I'll have to mention here is that, okay, not necessary, not necessary to have any balanced chemical reaction in this case. It's not necessary to have any balanced chemical reaction. Okay,
Yes, sir.
right. Now notice this example. Suppose I have KClO3, it is giving KCl plus O2. Got it?
Yes, sir.
If I say that, okay, potassium is conserved, potassium is conserved, which means that all of the potassium at the reactant is now converted, now passed into product, okay, which means imagine karo, in KClO3 there is 200 grams of potassium. Okay,
Yes,
I'm
sir.
not talking about the molar mass of KClO3, I'm particularly talking about the potassium atom only. If that 200 grams, I'm saying that has completely converted into product, whatever be the product is. But can I say that the same 200 grams should be present on the product side in any form if it
No,
is
sir.
conserved, right? Hence, I can say that here, if potassium is conserved, whatever be the number of atoms of potassium which are present here, that should be present across the product also.
Yes.
So now, as per the molecule here, can I say, if I have n moles of KClO3, okay, tell me how many moles of potassium will be present in it. See, 1 mole of
And
KClO3 contains 1 mole of potassium. If I take n moles of KClO3,
and
how many
more
potassiums you will have? N moles only,
and
right?
and
So I
moles of
can say
potassium. Yes.
n moles of potassium present in it. Okay.
Yes, sir.
And now check out on the right hand side, correct? There are some, you know, m moles of KCl. Imagine if there are m moles of KCl, correct? Imagine just m moles of KCl are there. So I can say m moles of potassium will be present in it. Okay.
Yes, sir.
So what I'm trying to say is, if the potassium is conserved, then I can say n moles of potassium on the reactant side must be same as m moles of potassium on the product side. Do you agree with that?
Yes,
This
sir.
is what we meant by principle of atom conservation. Okay. Let me write the same thing for oxygen. Let's say I write the same thing for oxygen. Okay. Imagine the case where oxygen is conserved. If I say oxygen is conserved, right? And if there are n number of moles of KClO3, okay, then that implies number of moles of oxygen atoms. How many that will be, beta? Can I say it will be 3 times of n or no?
And
Barabar? 3 times of n, correct?
yes, sir.
Because every 1 mole contains 3 moles of oxygen.
But
So if I take n moles, I should have
yes,
3 n moles of oxygen, correct?
yes,
Now let me read the same thing on the product side. Okay. If you have n is the number of moles of O2 at the product side, that implies number of moles of O atoms on the product side will be 2 times of m beta. And if oxygen is conserved, okay, sorry, applying POAC, I'll use this terminology from now. Applying POAC on oxygen, it implies 3n must be equal to 2m. Agreed?
yes, sir.
Which I can write it as 3 times number of moles of KClO3 is equal to 2 times number of moles of O2.
Oxygen. Yes, sir.
Yeah, this is how you should be able to write for any reactant to product. So it's not necessary that you need to have a balanced equation. Even without any balanced equation, you should be able to relate these kind of compounds with one another. All good?
Yes, sir.
Let me give you 2, 3 more examples like that. Okay. Suppose if I tell you P4 plus O2 excess, correct? It is giving P4O10 plus P4O6,
Sir,
right?
what does excess mean?
Excess means I'm giving sufficient amount of oxygen that the entire P4 is converted into this. There is no more P4 remaining after the reaction.
Yes, sir.
Okay. Hmm. So that means I'm making sure that phosphorus is conserved. That is what I meant.
Hmm.
Okay. Because if phosphorus is present even to a smaller portion also, that means you cannot apply POAC. Okay. POAC can be applied only when you have complete reactant converted into product. Is that making sense? Yeah.
Yes, sir.
Now check it out. What I could say is that now can I write this? Now I'm directly applying POAC. Applying POAC on phosphorus. So that implies 4 times number of moles of P4 must be equal to 4 times number of moles of P4O10
Yes.
plus 4 times number of moles of
P4.
P4O6. This is what is conservation of oxygen. Okay.
Yes, sir.
What if I give the same question in a different format like this? I'm telling you that I've given you the same thing, but this time the excess amount is on this side. Okay. And now I'm applying POAC on oxygen. if I apply POAC on oxygen. Devarshi, could you iterate what should be the equation?
Sir, it's, um,
Can I write this? 2 times number of moles of O2 that must conserve 10 times number of moles of P4O10 plus 6 times number of moles of P4O6. Please do let me know if you don't understand on these lines. Okay.
yes, sir.
Please go through the both equations and get an understanding and check if there is any uh, concept clarity missing. I can repeat it.
It's clear, sir.
Very good. Now we will solve one JE question. Okay. Okay. A typical standard JE question, how it is been framed. 27.6
Yes,
grams
sir.
of K2CO3 is treated by series of reactions to convert all of the carbon to K2 Zn thrice Fe CN6 2 times. Calculate the weight of product. Okay. Calculate the weight of product. Got it? Ha. Given, what is the other things given are molecular weight. Molecular weight of K2CO3 is given 138 and molecular weight of complex is given as 698. Devash, is this clear, beta?
Yes, sir.
Shall we do it together?
Yes, sir.
Chalo. Write along with me. What is the hint that you identified first? Try to identify the hint in the question. Have you noticed something here? Convert all of the carbon. That is a hint you should catch. Which means we should apply POAC on carbon atoms. Okay? Hint is clear?
Carbon.
Hmm. So,
Yes, sir.
write down there. Applying POAC for carbon atoms. Okay? What's the reaction that's taking place? K2CO3 is going through several reactions to finally form a complex K2Zn3 Fe
Fe,
CN6
and
oral
4O2.
twice. Yeah, very good. Have you written that?
Yes,
Hmm.
sir.
Now, please relate the number of moles of these two compounds using carbon, using only carbon.
1.
So, how do we do that, bacha? So, number of moles of K2CO3, which is same as number of moles of carbon, that should be equal to how many carbons are there here? 6, 6 to the 12, correct?
12.
So
Yes, sir.
12 times number of moles of
Number of moles of
complex.
this
I'll just put this
complex.
as complex, yeah.
Yes, sir.
And number of moles of K2CO3 can be utilized as weight divided by molar mass, 138.
Hmm.
That is equal to 12 times of weight of this, which is what I need to find out, divided by molar mass, which is 698 given. Okay. So
Hmm.
weight of complex will be equal to 698 cross 27.6 divided by 138 cross 12. Is it all making sense?
Yes, sir.
This gives us 11.6 grams, right? So this is how you calculate or solve the questions in these cases. Yeah,
Yes, sir.
right, beta. Okay. So I think you got an idea how to do this. Shall we solve one more question?
Okay, sir.
Will you do it on your own now completely?
Okay, sir.
Yeah, great. Let's take this example. Okay. This was also a previous year JEE question. Okay. For determination or determination of phosphorus in process, chemical process, got it? Magnesium, magnesium pyrophosphate, P2O7. Okay. Magnesium pyrophosphate magnesium pyrophosphate is prepared.
Yes, sir.
Okay. Hmm. Using sodium hydrogen phosphate
Hmm.
solution. Got it? By following steps. Sorry, by following reaction. This reaction was given, that is Na2HPO4 plus magnesium 2 plus ammonium is giving us, okay, Mg NH4 PO4 dot 6H2O, which on further heating is becoming Mg2P2O7. Okay, right. If 2.054 grams of Mg2P4 is uh, weighted, find the initial mass of Na2HPO4. If you are stuck anywhere, you could ask me for the hint. I'll help you out. Okay. But think through first. Try to apply the POAC. Okay, beta. And check whether you are
Yes, sir.
able to arrive at an equation. Okay, you will be doing this, applying POAC on phosphorus, right? Hence, what we can say when you apply, basically here the main labor job what you need to do is finding out the molar masses of this and this, correct? That's where some will be lost. 1 second, I think. Let me reshare the screen. Right, check. I am supposed to apply POAC on phosphorus. So you can see what I can write. Number of moles of Na2HPO4, that must be equal to 2 times number of moles of Mg2P2O7. Do you
Yes,
find
sir.
any doubt in this step?
No, sir.
Very good. So in that case, I can write it as weight of Na2HPO4 upon molecular weight of Na2HPO4, that must be equal to 2 times weight of Mg2P2O7 upon molecular weight of Mg2P2O7. Okay.
Yes, sir.
And thus, using this, we can write weight of weight of Na2HP4 will be equal to 2 times of weight of the product, which is given as 2.054 by molar mass. The molar mass of this is 222. That multiplied by molar mass of NHPO4, that is 120. When you work out, you'll get this value. Okay, beta.
Yes, sir.
As you multiply that here, this multiplication, everything comes out to be, this entire thing will get cancelled off. So you will have this as exactly 2.22 grams. Clear?
Yes, sir.
Right. POS is something new. It will take some time to adjust. You need to solve multiple number of questions in these cases. Now she understood, beta. So
Yes,
today we discuss main three concepts. That is percentage purity, percentage yield, and identifying
yes,
equations using POAC.
yes,
Okay.
sir.